Okay, we're doing this problem where we evaluate a double integral. This is from multivariable calculus. So we have this integral y squared dA, it's a double integral, and we're integrating over a triangular region. Truth is, I have not done this problem yet, but I just feel like, why? I should be able to do this. Okay, so we'll see though. So what I'm going to do is I'm going to plot these vertices and find out what the triangular region is. Let me switch colors. All right, so 0, 1, I'll put a little point for that. 1, 2, that's over here. 4, 1 is over here. So here's our triangle. Okay, I would have to say this would have been a better picture if I had just made it bigger. But besides that, I think I nailed that part. Unless there's anybody who thinks otherwise. Any questions so far? Seems that's okay, right? Okay. Now the thing is that we have this region D, and what we need to do is determine how are we going to view this region. It's a type 1 region, which means a function on the top, and then a function bounded by a function on the top, and bounded by a function below. Or should we look at this as a type 2 region, which has a function on the right-hand side and a function on the left-hand side that bounds it? And I would say that I think it's more convenient to do type 2 because on the right, here's one function, and on the left, here's another function. So that's two functions. Well, if I were doing type 1, which is totally fine if you want, you would have to break this up into two integrals where I have a top minus the bottom, and here's a different top minus the bottom. So the question is a bit, now can I figure out what this left-hand line is? It's a line, so it's going to be of the form y equals mx plus b, at least as a start. And so I notice that I have an intercept of 1, so I'll put 1 there, and the slope I can see is 1. So that's x plus 1. However, because I'm using this as a function on the left, I want to turn this around right. X equals y minus 1. Now, on the right, I guess I have to look at this a little more carefully. If this is y equals mx plus b, then what I see is that, well, I can find the slope pretty easily just by counting. So I'm going down by 1, so that makes negative 1, and to the right by 3, yeah. Okay. And then the thing is, I don't know what b is, and so what I'm going to do is I'm going to just plug in I'm going to put in x equals 1, y equals 2. I mean, this is not the only way I can do it. I can use the point slope form. That's maybe a better way. But anyway, so that b is equal to 2 plus 1/3, which is equal to 6/3 plus 1/3 is 7/3. So if you guys don't agree with that, let's speak now. Let's go ahead and put in 4 to make sure. 4 times negative 1/3 makes negative 4/3 plus 7/3 makes 3/3, which is 1. Okay, so it seems putting in 1. Okay, so this seems to work. I'm going to do the same thing. Well, first I'm going to express x as a function of y. I'm going to multiply everything by 3. And then I'm going to, I guess I'll bring x to this side. And so x equals negative 3y plus 7. All right, so this gives the right, and this gives the left. So I have a type 2. And so d is equal to all xy such that y is between, as we see, y is between 1 and 2. While x on the left is x plus 1. Sorry, y on the left is x plus 1, and then y to the right is negative 3y plus 7. You're in the video. Oh no, you went around it. Okay. Okay, and so then we're going to integrate this, and we integrate with the number, the variable with the numerical last, so I'll put that 1 to 2, dy.
Professor, it applies where?
Oops. Yeah, thank you. Would have gotten the whole thing wrong. Awesome. Okay. And then I'm going to go over here. Y equals x plus 1 to x equals, I might do 7 minus 3y. I don't know. I'm just going to do that. And that's dx. Because this is, okay, so as everybody can see, I seem to have done something wrong here. This is x equals negative 3y. This one's right. This is x equals y minus 1. It's all wrong the whole time. So this is x equals y minus 1. So I want, and this is x bounded by this. Can I keep the video? I'm just going to keep it. Okay, anyway, sorry about that, everybody. So y is between 1 and 2. X is between these two functions of y. All right, so x equals y minus 1. X equals negative 7 minus 3y. So this is x equals y minus 1. X equals 7 minus 3y, y squared. And then I'm going to integrate dx. This is a constant with respect to x. So I have 1 to 2 y squared x from y minus 1 to 7 minus 3y dy. So I just plug in x is 7 minus 3y, subtract x is y minus 1 dy, and then, I'm going to simplify, and then 7 minus 3y minus y plus 1 dy. So this is 1 to 2 y squared. Negative 3 minus 3y minus y is negative 4y plus 8 dy. So I'll get 1 to 2 y squared times negative 4y is negative 4y cubed plus 8y squared. Okay, and then we just, continue integrating. So we'll get negative 4y to the 4th over 4 plus 8y to the 3rd over 3 from 1 to 2. So I'm going to write it like this. So this is y to the 4th from 1 to 2 with a negative plus 8/3 y to the 3rd from 1 to 2. So this is negative 2 to the 4th minus 1 to the 4th plus 8/3. 2 to the 3rd minus 1 to the 3rd. So this is negative 16 minus 1 plus 8/3. 8 minus 1, which is negative 15 plus 8/3 times 7. So negative 15 is negative 45 over 3. And then 8 times 7 is 56. So this is a positive number. Let's go back to this. This integral here is positive, or it's not negative. It's never negative. So our integration, our final answer should be positive. So that's hopeful. Sorry, don't have the answer in the back of the book. Anybody see if that, did you look in the back of the book maybe? Anybody? No? Okay. But seems like it could be good. All right. So